Good evening, folks. We'll be getting started with our INTROSEC stream in just a minute here. Okay, let's get started here. So, just as a preface, there's a couple demo files for today's talk. So, if you pop over to the tools website, which is linked in the slides, or you can just go to tools.rpas.ec, and that will bring you to a list of our downloads for today. Check out forensics demos. And if you don't have a Linux machine, you can grab our tools VM, which is also linked on the tools website, and you can drop that into VirtualBox, and that will contain everything you need today. So, what is forensics? So, at a high level, forensics is the process of kind of finding and analyzing evidence. Typically in the context of kind of criminal forensics, you're looking for evidence in of a crime, for example. Digital forensics is therefore anything forensic that is done with digital devices. So this could be pulling data off of a locked iPhone and then the FBI having to plead with Apple to do it for them, because they're bad at it. Things like finding evidence of wrongdoing. So maybe you think somebody stole a bunch of company secrets. Well, can you prove they did it? And then it also covers things like deleting your files, which I think we all kind of had to do one point or another. So all of these things involve finding information that might be hidden and making sense of it. Turn my volume down a bit there. Sorry, that should sound a little nicer. So there's a lot of things we can analyze here. We have, plain text logs. So this is, the classic text-based logs you might get from a web server or from, your Minecraft server, that kind of thing. You got things like network traffic, the actual data flying around your computer system. There's file system metadata, things like last access time and all these other kinds of attributes. There's recovered data, meaning that, maybe your hard drive crashed and you're trying to pull data out of it. Or, maybe you captured some data from a computer before it deleted itself and you're trying to repiece, put all back together. As well as you can go as far as full system memory dumps, as in you take a snapshot of a computer, every single bit of it as it's running, and you actually look at it and kind of unpack what was going on. If you have access to kernel memory, you can see exactly what the computer was doing, as well as see exactly what malware was running, that kind of fun stuff. And so this stuff, has a variety of real-world applications. So why is our entire, computer network infected with ransomware? Well, it's because our smart toaster that we plugged in 3 months ago was immediately owned and has now just been deploying rootkits to all our computers. Less dramatically, what if we want to know, we fired Bob, but we think he might have stolen some company secrets. So what did he look at last week? Well, Windows, for example, stores a lot of metadata. It's the beautiful thing called shell bags. It's a great name. I think it's something from your Explorer is a visual shell, and that's like a bag of data. They show a fun little thing to read here if you want to learn more about that. But you can actually kind of work out exactly what somebody was doing on the computer, like that. And you might also want to know, okay, where did that banking Trojan send all of the customer social security numbers? Well, if you have good logging, you might know. You might not. So these are some of the real world applications. Things that, and especially it's kind of, we're thinking about forensics as in finding evidence or of wrongdoing or finding information about wrongdoing, and that's where classic forensics kind of lives. And you might see the term blue team used to describe this, and they kind of go along with the red team. The red team they try to test the security of the system through offense. The blue team ensures security through defense. So responding to things going wrong and figuring out why things went wrong. And a big part of that is understanding like what happened, when did it happen, why did it happen, all those questions. And that's what real world forensics kind of deals with. You also see forensics in CTFs. And I kind of liken this to steganography, but less of a meme. So instead of giving you a picture of a stegosaurus with the B movie script kind of embedded inside of it, they give you a memory dump, or they give you some corrupted files, and you try to extract some secrets from them, or find out what's going on. So it's, I guess you could almost just say it's real world stego. You might say that. But yeah, so that's where you might see this, and it's not as common as a category as something like home or reverse engineering, that kind of thing. But you still see it now and then. So we're not going to focus on these things too much, but just as a bit of a review, some of the tools we've already covered this year are very relevant for forensics: strings, grep, binwalk. Just a quick refresher on those. So strings will find real, human readable text in a giant blob of non-readable text. It kind of just scans through the file and looks for things that look like actual text. So it's not just a bunch of weird, incomprehensible characters. It's actually like letters and numbers. And if we pop open our virtual machine here, and I just go into the forensics demo here, run strings on this blob, you get a whole bunch of stuff here. And the RPSec pizza party is at 2 a.m. Yeah. One handy thing with this, if you give it a number like N10, it'll filter everything out that's shorter than that. Makes it a little easier to parse through. So yeah, that's pretty classic. Grep allows us to look for things. So, for example, we might look for a message sent by evil hacker here. And if I just grep evil hacker, log that text, there we go. Password is swordfish. And a handy thing with grep here, you can actually ask for things before or after the thing you matched, or both. And that is very handy if you're looking for something nearby you actually match. In this case, it's just a noob trying to download some RAM, so not so useful there. But I put the effort in. And the most interesting one I think here is binwalk. And I think I've extolled its virtues plenty of times already. But just kind of as a reminder, it allows us to dig through a file to look for telltale clues of things inside of it. So, for example, if we look at this blob here, I don't know if it's going to find much. Yeah, this looks like garbage. But if I run binwalk on this file, it will actually, let's see. Oh no, did not find the images. This is embarrassing. Oh, this image is, I think this is broken. Oh, sorry. I used the wrong file. That wasn't embarrassing, it was just wrong. Anyway, binwalk on images will find that there are the telltale signs of image data at these three places. So, for example, if I had a 16 gigabyte disk image on my flash drive that got blown up, but I managed to get an image off of it, I could binwalk it to see what's on there. And if I want to get things off of it, I can just add a DD here, and you tell it just give me any file at all, anything you want. And it'll unpack it, and there we go. And if I pop these open in fair, I got some really contemporary images. They're beautiful. Yeah, get out of here. So yeah, there's some things we've already talked about, I think, and it's still very nice to keep in mind. Let's come back to the slides here. So yeah, binwalk will both traverse and unpack files, so very handy. And yeah, these are very forensically relevant. The logs will tell us who set up us the bomb. But I think the focus of today is going to be on networking, specifically how to analyze logs of networks. So a lot of nefarious computer activities involve a network. So, for example, just like with the smart toaster that destroyed our entire computer network, Alice might get her computer pwned by Eve because she installed Bonzi Buddy 4 or whatever. And Alice's computer can talk to Bob's computer. And oh no, our network is configured terribly. Now Eve has access to Bob's computer. Eve has stolen the recipe for Coke. Pepsi wins. Now, I think that's great. But nominally, blue team, we want to stop this. So, but suppose we discovered this happened after the fact. And what do we do about that? If we want to actually, go back and say, okay, what happened here? How did this happen? Who did what? That's where packet captures come in very handy. And corporate networks will usually have monstrously complicated and expensive security appliances carefully monitoring all this data to figure out exactly what's going on in the network and figure out, according to the vendors at least, who attackers are before they can hurt you. In reality, I think they mostly hurt your wallet, but that's another talk. So this was captured using Wireshark, which is a very nice piece of software, and it is pre-installed on the virtual machines for you. Before we fire it up, we're just going to step through this here and see what's going on. So this is me just downloading example.com. And it's a lot of gobbledygook here. Let's go through it bit by bit. So we ask first for where example.com is. And you'll notice, so we go from, this is my IP address, and I go ask like a router or something, and it just responds back with the IP address. And we asked both for the IPv4 and IPv6 addresses, A and quadruple A, respectively. So there we go. That's what we connect to. And if you peek down here, you see we have the same addresses. The bit in the middle here with the ARP that's address resolution protocol, and it's not really relevant for us today. But I will note that this is basically you asking your network, hello, everyone. Would somebody please tell me how to contact some so-and-so? And there's no reason that somebody can't lie. But I'm sure that would never happen. I'm sure that ARP poison routing doesn't exist. That's all good. So anyway, we got ourselves an IP address, and now we establish a connection. And this is classic TCP. We send a SYN packet, they send a SYN-ACK packet, we send an ACK packet. Now the connection is open. And you can see we got all this data here. We got like sequence numbers, and we got, window sizes, all sorts of fun stuff. We won't dig into that today. That's a whole networking talk of its own. But it's all laid out there. And then we just make a request. I say, okay, get HTTP, give me the root, and it responds, okay. And at the end, we just close our connection. And we send those FIN packets here, and that closes it. So that's the entire connection there. You notice that this didn't have any HTTPS stuff, because TLS makes it a lot more complicated. But actually, we'll see that later. So, as I mentioned, this is captured on Wireshark. It is pre-installed on the Tools VM, and it's easy to get otherwise. I think it even works in Windows. You will find in the demo folder some example files. For example, example.com.pcap, which should be the exact same thing that I just showed in those screenshots. And you can open them from the GUI. So let's pop over to Wireshark here. Just type that out, enter. And we'll see all these different things that we can listen to. But for now, we're just going to go open forensics demo and example.com.pcap. So there we go. We have all this stuff laid out here. We click on it, we can inspect it, we can see the whole response here. Hey, look, CSS. Very beautiful. So that is that is everything. This is literally everything that's going over the network. So that you can imagine it gets quite large, but it is extremely detailed. So Wireshark will allow you to view captured packets, as a whole, as well as carefully inspect them. And it will understand quite a variety of protocols. It gets all the common ones, but if we just, just as a hint here, if I look at all these like things in this list here, like some of these are like attributes, but other things are just like actual. There's like DOCSIS, and that's like that's how they put data over cable. Cable internet is actually just IP over MPEG. It's pretty terrifying. So it handles that. It handles systemd journals. It'll handle a lot of stuff. So it's a very flexible tool. You mostly use it to analyze, TCP traffic, but it's out there. Yeah, and so here's just an example. I can actually look at a DNS packet, or a packet that was sent as part of the DNS request, and see, like I'm asking the DNS server for the IPv6 address for a website, example.com. So if you just click on one of those packets, you'll see all of its contents. This is an example here. This is from the chat PCAP file. I've highlighted this packet here, and we got all this stuff down here. And you might remember something called the OSI model. It's like that. It's that 7-layer thing, but really only 5 because nobody really cares about these two. And actually, if you look here, that's our OSI model. We have layer 1, layer 2, layer 3, layer 4, and then layer 7, the application. And I can highlight these to actually, see what part of the packet that corresponds to. So this is actually really nice for, like learning and understanding how data is laid out here. So for example, this packet here, like say my GET request, so the Ethernet stuff's down here, and that is bouncing around a few interfaces. We got, that's just like the, where it's going from, where it's going to locally. We got the internet protocol layer, which tells us, okay, where do I want to go? And go into this address over here. We got the TCP level, which actually handles, reliable connections. It handles sending data again if it doesn't get received, all that good stuff. And then finally, we have the actual application layer. And you can see here we got, get, HTTP, host, example.com, all that good stuff. So we can actually inspect in very, tight detail what is going on. And this kind of careful inspection is used by things like intrusion detection systems that kind of say, hey, that traffic is kind of weird, why is it going, we don't talk to those IP addresses. Why are we going to them? That kind of thing. So yeah, that's the kind of taste what that can do. Now, one problem is that computers can send lots of packets. For example, I'm probably sending thousands and thousands of packets right now. I'm streaming at like 4 megabits per second. That's got to be a fair bit of packets going. And digging through all of them is tedious. If we open up the file called bees.pcapng, we got a lot of packets in there. And originally, I had to confess, this is going to be a funny joke where it was a bunch of Google searches that, like, a man descending into lunacy at the thought of the Bee Movie 2, but TLS executed all of it. And if we have a look here, you'll see that if you capture packets with like encrypted traffic, it just doesn't know what's going on here. TLS, there we go. That looks good. I can't understand any of this. We can see, I think we might be able to see where it's going. Actually, TLS 1.3, I don't think it even lets you see where the thing's going. It's very thorough. You can actually get around that. You can you can install a certificate that will allow Wireshark to decrypt all the traffic, but I didn't do that here. So you see, regardless, there's a lot of garbage in here, and I don't want to dig through all of it. So we have filters to help us deal with that. And that's what that big bar at the top does. It is, you basically put a query in there, and it then filters the results down to just those things. So you type DNS, you only get DNS packets. DNS.quad-A only shows IPv6 DNS responses. So like if I do DNS AAA, we get just one thing here, the query response that gave me the IPv6 address for example.com. And then you can say things like filter on destination or filter on source, as well as things like filter the first 100 frames, that kind of thing. Or, ignore everything in the 10.xxx range. So these are very flexible and, obviously very important if you're going to be making good use of, packet captures, because you're typically going to get a lot of traffic, and most of it will probably be totally irrelevant. So in this capture, I actually sent a secret password to example.com at some point. So let's find that. So the first thing we'll do is figure out what the IP address was. And with this filter here, we should be able to get down to just what, the actual response by the server. So let's do DNS query.name equals example.com. And let's see, what was the other one? I think DNS.a. Yes, there we go. So we have a single packet here. It's number 6,679, sent from my machine to local router there. And it tells us that it is at 93.184.216.34. So there we go. We found our address. Now we just filter by the IP address of the target. So IP.just host equals 93.184.216.34. Add on the code there. And there we go. So we filtered down to just the traffic sent from our machine to the web server. And if we look there it is. Password is forensics time, which is I think it's a great password, if you ask me. And you can see here, this is actually one of the problems of just putting passwords in your GET requests and then throwing them over unauthenticated, authenticated but unencrypted HTTP. And back in the terrible old days, this would allow somebody at your local Wi-Fi, coffee shop to steal all your passwords. Thank God for the advent of TLS, and say that much. So there we go. And if we poke around in here, we can actually see all the different bits of the frame here. Like we see the Ethernet part, we see the Internet protocol part, the TCP part, and then the actual data. It's kind of just a big onion. Kind of peel off bits and, move along all the way down to that physical layer. So you can also record your own traffic if you want. If you pop open Wireshark there, just, reopen it, or, and you'll get this capture menu, and you can just pick an interface and record it. Nominally, you can even do things like Bluetooth, USB, and most interestingly, I think, systemd journal. So, there's a lot of things that this thing can actually process. Again, a very flexible general purpose tool, not just for analyzing your classic internet protocol traffic, So yeah, that should wrap us up for today. Pretty quick, but we kind of just talked a little bit about one of the main kind of components of digital forensics, that is networking. So this Friday, we're going to go into some more gory details on some other aspects of forensics. I believe we'll be covering things like maybe more advanced use of binwalk or tools like Scalpel for really just, extracting data, as well as I think we might get into some really spicy stuff like looking at memory dumps. But we'll see what pans out then. So definitely stop by on Friday and say hello. And feel free to join our Slack as usual. Just need RPI email. You can hop on there and come chat. We're going to be playing some more CTFs and generally, doing some cool stuff over there. So stop by if you can. And thank you for coming.